there. Hope you're fine. Welcome to my YouTube channel. This is Flipno explaining. So in today's class, we are going to discuss or to look at the relationship between the EMF and internal resistor. Remember, EMF in full electromotive force. Enjoy. So let's look at the relationship between EMF and internal resistance, and let's start by defining what EMF is. EMF of a cell is the PD, or the potential difference between its terminals when no charge is flowing out of the cell. I mean when the cell is in open circuit. So if a resistor R, let's say a resistor R is connected, if resistor R is connected in series with a cell. I shall draw here a diagram. You shall see the internal resistance of the cell R, and let R be the internal resistance of the cell is considered to be connected in series with the external resistor R. This capital R is the, let it be external resistor. So here is a sketch or an illustration to show what I'm saying. This is the cell, then this is the internal resistor. Can have R here. Is E, then here is the current R. So the current flowing in this circuit is therefore given by this equation. Current is given by the EMF over total resistance. EMF over total resistance. So the current I is equals to the EMF denoted by E over total resistance. What's the total resistance? The external resistance R and the internal resistance are small r. I'm saying the total resistance is equals to external resistance capital R and internal plus the internal resistance small r. So R plus R, where E is the EMF of the cell. This is the EMF of the cell. Thus, can say that E is equals to R plus R. Remember, you can multiply both sides by R plus R to get rid of this denominator capital R plus small r. So the EMF is given by R plus R. Times I for current, R plus R times the whole of these times, that's times I, the current. So to open the brackets, we get IR plus IR. But remember, Ohm's law that V is equals to I, V is equals to IR. So this IR we can replace or substitute V here, and you have V plus IR. So IR, this IR is the voltage drop across the external resistor R, while IR, this one, is the voltage drop across the internal resistance. resistance. Hope you understand what I'm saying. And the voltage across the external resistor is called the terminal voltage. While the PD, or the potential difference drop across the internal resistance, is called the lost voltage. Or in simple terms, you can say that the terminal voltage of the cell is the potential difference of the PD across the cell when the circuit is closed. So let's look at one example where this formula, or this relationship, or this relation is applied. Example. Here is the example. A battery consisting of 4 cells in series, each of EMF 2.0 voltage and internal resistance 0.6 ohms, is used to pass a current through a 1.8 ohm resistor. Calculate the current through the battery. Solution. We have been given presented with have 4 batteries, each of EMF 4 batteries, or 4 cells, each of EMF 2.0 volts, and internal resistance 0.6 ohms. It's used to pass a current through 1.8 resistor. So 1.8 ohm resistor is the external resistance. Calculate the current. You have been asked to find out to determine the current through the battery. Remember, many cells, 2 or more cells make up a battery. So the current through the battery, current I through the battery is given by EMF of battery over the total resistance. Remember here, I is given by the EMF over total resistance. So E over R plus R. So the EMF of the battery is the sum of the EMF of all the cells. Remember, each cell contains 2 or 2.0 volts. So the total EMF is 2.0 times 4. We get 8.0 volts. While the internal resistance of the battery is the sum of all the internal resistance of the cells. I'm saying that the internal resistance is the sum of the internal resistance of the cells. So each cell has an internal resistance of 0.6. Are you there? Ohms. So the total internal resistance will be 0.6 times 4 cells. Are we there? So the EMF for this one now will be 4 times 2.0 volts. We get 8.0 volts. And now R, the total internal resistance will be 4 cells times each 0.6 ohms. We get 2.4 ohms. And now the current through the battery, I, will be given by total EMF 8.0 over R, this is the external resistance, 1.8 plus the total internal resistance 2.4 ohms. This gives us answer in ohms. And now you have 8.0 over this is this plus this is 1.8 plus 2.4 is 4.2, and now our answer is 1.905 amperes in 4 significant figures. Hope you understand. Thank you so much for watching. Kindly do subscribe so that you'll be getting the updates and notifications the moment I'll be uploading a new video. See you.